Good afternoon. This is Mr. Veron with the solution to yesterday's problem of the day from April 28th. So it says Lee wrote the number sentence below to represent the rule for his input-output table. N plus 3 equals P, where N is your input, P is your output. So part A says use Lee's number sentence to complete the table. So if you look there, his inputs are 1, 2, 5, 10, and 12. And you have to figure out what his output will be based on the rules. Part B, Lee's friend Maya wrote the input-output table below. So her inputs are 5, 6, 8, 12, and 21. Her outputs are 3, 4, 6, 10, and 19. Write a number sentence to represent the rule for Maya's table. Use N for the input and P for the output. Part C, a new input-output table is shown below. So the inputs listed are 1, 2, 5, 7. You have to find the last input. And the outputs listed are 4, 20, 28, and 36. You have to find the second output. Write the missing numbers to complete the input-output table. Show or explain how you found your answers. So if we look here at the solutions to this problem, so the first one's fairly simple, okay? We have the inputs which were given, the 1, 2, 5, 10, and 12. We were given the rule N plus 3 will equal P, or our output. So in this case, we're just going to plug our inputs into the spot of N, and that's going to figure out what our output is. So if we look here for the first one, we had the input of 1, so we're going to plug in 1 for N. 1 plus 3 equals 4. So our output, or P, is going to equal 4. Same thing for the next one, N plus 3 equals P. So we're going to plug in 2 for N, 2 plus 3 equals 5, so 5 is going to be our output. On our next one, N plus 3 equals P. Again, I'm going to plug in 5, so 5 plus 3 equals 8, so 8 will be our output. Our next one, N plus 3 equals P. Our input is going to be 10, so 10 plus 3 equals 13. So our output is 13. And on our last one, we had N plus 3 equals P. So our input was 12. We plug in 12 for N. 12 plus 3 equals 15. So our output is going to be 15. So that completes the chart for the first one. Now we've done input-output tables before. This is a horizontal version. We've done them vertically. We can also call it a T-chart. The one thing you got to be careful of here, so this is one where we see a pattern from our input to output, but we actually don't see a pattern on our inputs or our outputs from one to the other because they're not counting in any type of consecutive or pattern. They're just counting randomly, so 1, 2, 5, 10, 12. There's no pattern to that, so you don't see a pattern in your input or your output. So you got to be careful on these. Now on the next one, so our input output. So again, we had an input of 5, the output was 3. Our input was 6, our output was 4. Our input was 8, our output was 6. Our input was 12 and our output was 10. And our input was 21 and our output was 19. So the first thing I notice is we have a decreasing number pattern. So typically with decreasing number patterns, you want to look for some type of a rule that's going to involve typically subtraction or division. So when we're looking at this, I'm trying to figure out how would I get from 5 to 3. So if you see here, I marked a little thing minus 2. Now there was nothing for division. There's nothing I'm going to divide 5 by to get 3. So now I just got to see, does that minus 2 work for every single input-output? So in this case, how do I get from 6 to 4? Minus 2 does work. How do I get from 8 to 6? Minus 2 works again. And we see that it works from getting from 12 to 10 and from 21 to 19. So my rule for this is going to be a subtract 2 pattern. So when I do this, I'm going to do N, which is my input. I'm going to subtract 2 all the time. And then that's going to equal my output, which in this case is going to be P. So here's my number sentence or equation, as we like to call it in 5th grade, for this input-output table. Now, when we get to part C, it gets a little trickier So we have an input-output table, and we've got to figure out what the rule of it is in order to fill out the missing pieces. So in order to figure out the rule, again, I'm going to look at the ones that are given. So in this case, I'm going to look at the 1 and the 4, the 5 and the 20, and the 7 and the 28. So when I'm looking at this, again, I first start off by thinking about what kind of pattern am I looking for. So I'm looking for an increasing pattern. So if I look here, how can I get from 1 to 4? Well, I could add 3, or I could multiply by 4 to get there. So now what I want to see is there a pattern with addition, or is there going to be a pattern with multiplication here? So I go to my next set of numbers. So 5 to 20, well, I would have to add 15, and times 4 does work. So I'm already thinking that times 4 is my pattern, but I'm going to double check again by looking at my next number. So I have 7 and 28. Now again, I would add 21 to 7 to get to 28. And then I could also multiply by 4. So in this case, I'm going to use the multiplication pattern because you see there really is no pattern to the addition. So in order to figure out the first part, if I have 2 as an input, well, I just plug 2 into my times 4 pattern. So 2 times 4, my output is going to be 8. So 8 would go in this empty box. Now it gets a little trickier when we come here. So when we go to the last one, if I know that I have a times 4 pattern, now in this case, they actually give me my output. So it's n times 4 equals 36. So really what I'm trying to figure out is what number that when I multiply by 4 is going to equal 36. Now if you know your basic facts, which hopefully some of you know, you would realize that 9 times 4 equals 36. Now, if you don't know that, you need to figure it out. We actually have to work backwards. We've talked about this word before. It's called the inverse operation. So we're really working backwards in our number sentence. So in order to do backwards, I have to do the opposite process. So in this case, I'm using multiplication. So the opposite of multiplication, or the inverse of multiplication, is division. So in this case, I'm going to do 36 divided by 4. And 36 divided by 4 equals 9. So that gives us our missing piece in our last box. So hopefully you got the same solution, and look forward to today's problem of the day coming shortly after. Thank you. Bye.